Welcome to Flower Turbines in Lubbock, Texas. My name is David Beatty. I'm the facilities manager here, and we'd like to just give you all a look around at what we have going on and what we're developing. This is our manufacturing facility where we do our CNC machine work, our packaging. This is our CNC lathe where we manufacture our rods. We're in the middle of a setup right now on it, so it's kind of why it looks the way it does. This is our new CNC mill where we are going to be using it to drill our small turbine rods, the cross holes for the rods in it. This is one of our new 2-meter designs. We're figuring out the center column spacing and design for that. And these are survival units that we're selling for people that are camping, want to be off-grid. They're available in a multitude of colors, designed to be used with solar batteries. One thing we've found with our product is that if you space them correctly and in a cluster, we have dramatically improved efficiency output, somewhere in the range of 200% versus a single turbine. These back here are our original design with the fiberglass blades. The new design with the ABS blades are going to be much more cost effective and much better production of energy. So we've made a lot of strides in where we started at. And this is our ZW pole. It is a hybrid controller of wind and solar for college campuses, facilities such as that. It is designed to charge cell phones, laptops, e-bikes.
So hi, I'm Jonathan Forbes. I'm the lead electrical engineer here at Flower Turbines. And this is a look in our electrical engineering prototype lab. And so here we have various equipment. We've got a full solder station. We have some various electronic loads, oscilloscopes, power supplies, all the different equipment that we need to do electronic controller prototyping. So what are we doing here? Well, we want to develop electronic controllers that can efficiently convert the power generated by the turbines, either to convert it in a way to store it into batteries or to push it onto the electrical grid. So we develop the electronics here, we bring in some off-the-shelf electronics and we test them here, and the entire goal is to efficiently convert power from the turbines and store it either in batteries or push it onto the electrical grid. So let's take a quick look around the electronics lab. So we have a full wire rack of different wires that we use as part of prototyping. We have some of our components, some of our inventory here in bins. These are going to get built into the 1 meter and 2 meter electronics as we move forward. More of the inventory here, and of course we're purchasing more inventory as we're building up more controllers for the various turbines. Here on this workbench is some of the equipment, electronic test and development equipment we use when developing and testing our electronics controllers. Oscilloscope, soldering equipment, electronic loads, power supplies, and we have more equipment, but this is what we're using currently at our current development stage. And various tools. We've got some more off-the-shelf controllers we're looking at here at possibly integrating into our controllers as well to help save on costs. And the entire goal here is to develop electronic controllers that are cost effective, but also in the most efficient way can convert power from the turbines to either store on batteries or push to the grid. So here's an example of one of the prototypes, one of the early model prototypes that we developed. And as you can see, it's in not totally connected at the moment because we're doing some various testing on it. But this is an earlier model, and we're currently working on making it a more mature design and working on the manufacturing and manufacturability of this product.